And our next speaker is Thomas Dimson from Instagram. One button, real easy.
So, hello. I'm Thomas. I'm from Instagram. I've been at Instagram for about 4 years now. I'm a software engineer. Generally, I work in different organic content ranking situations. So you can imagine kind of like an ads problem, but applied to real people, which makes it kind of interesting. If you don't know, so Instagram is actually, I like to make sure we're all level set here. Instagram is a social network. Some people think it's like a filter app, but it's actually a social network with 400 million daily active users on quite a growth trajectory that's just on a tear. Every month we have over 600 million people using the app. Today I'm going to talk to you about, well, measurement, which doesn't sound very exciting, but I'm going to talk to you about something that happened to us in the feed space. So this is feed, there you go, which is basically a list of photos taken by people that you follow on Instagram. And in particular, I'm going to tell you what happens when you take this, which is your feed in an abstract sense, ordered by post time, and you do a little manipulation, and now you sort it by something else. And that very subtle difference, doesn't look like very much, gives you something very scary, which is this plot. It's an increase in feedback, comments, likes, that sort of thing, as a result of our test, which deployed a ranked feed versus a non-ranked feed. Obviously, I can't disclose the y-axis fully, but I will say that the x-axis is definitely the number of digits in that. And for machine learning, anything that's a double-digit gain is kind of insane. So we actually had this problem. It's like, this is almost a problem of success, because what's going to happen is we're now opening the floodgates, and all this water, all this feedback is coming through the entire social network. And the question is, how do we deal with that, and how do we reason about that? Because in social networks, you can run A/B tests, but actually, whether you care or not, there's subtle interactions that are going on. I just said that I followed a bunch of people, and that's why I'm seeing their content in their feed. Well, if I'm interacting with them more, that's going to affect their behavior. So there's a cross-pollination between control and test groups. Usually it doesn't matter. Usually it's like, oh, the effect is so small, it's not going to matter. But when you're extremely successful in a project like this, suddenly you have to start reasoning about things. So this is our ranked feed timeline. I think it was alluded to at the start of this. We actually just hacked it up in a hackathon in November. We had it out to a public release in June, which I thought was pretty good. And in particular, I'm going to talk about this period right here, which is from March till June, which is our testing period. So we didn't want to just kind of YOLO a huge giant test at once. We wanted to be very principled about it, so we released to 1%, got a bunch of servers and capacity, and did lots of planning and that sort of thing, and slowly ramped it up to a worldwide rollout. I also sometimes call this period "don't screw up," which is because actually, literally, this was said to me by leadership, is oh, it looks great, don't screw it up. And so it was a pretty important project. Again, very subtle. Most people don't even know that the Instagram feed is ranked, but it is, and it results in a lot of things. So, okay, to level set, what is ranking, or how do I think of ranking? If this is your feed, again, ordered by post time, there's another way we can kind of look at this feed, which is in terms of sessions. So, same feed. Now, instead of looking at just ordered naively by post time, we can look at different times of day. So imagine you're going to sleep at 11 p.m. When you go to sleep, you open the Instagram app, you see there's 10 photos, that's cool. You go to sleep, you wake up at 9 a.m. over the night, maybe people on the West Coast have been posting all kinds of crazy stuff, and so you have 50 posts. You put the phone down, pick it up again, you have one post that's new, and then finally you put it down, you pick it up again, you have 10 posts that are new. And in a time ordered thing, it doesn't really matter if you divide this section, it's kind of equivalent. But there's a problem with this, which is that you're lazy. Everyone's lazy. I'm extremely lazy. Obviously, I'm not going to scroll through 50 posts in the morning. I'm going to wake up, have a sleep, maybe go down 3, and then I'm done. And we actually measured this at the time when we were doing this feed ranking project. We measured that something like 70% of impressions or of eligible content goes unseen by people, which is kind of a scary number when you think about it. So what will happen is like, okay, it's 11:30, your best friend calls and says, can you believe I'm getting married? And you're like, wow, congratulations. You missed their post because you were too lazy to scroll down to see your friend's wedding. It was drowned out by some other people that maybe you just didn't care quite that much about that particular post. So how do you fix this problem? Okay, so there's two things that I can think of. One is that we can make you follow fewer people. Like the problem really is that you have too much content, that some of the best content in your feed is being drowned out by this like randomly ordered or even worse than randomly ordered chronological content. But that doesn't really sound like a good thing to do. Like, are we really going to make you curate your graph and try to make it as pure as possible? It's like not a good user task. So the only other way I know of fixing this problem is to violate your chronological assumption. So this is the least exciting slide in the entire world, where all I've done is taken the feed on the left, and then I've run it through some magic ranking function that produces the feed on the right, which looks exactly the same, but is now in a slightly different order, at least between those time periods. So there is still the concept of time, and there's still like, oh, there's content that comes in since the last time you checked the app, but it's now in a different order. And so usually the way we like tell this to people in a way that people understand is that we're putting the people you care about first, which is a really nice way of phrasing this. Of course, if you're thinking, you should probably be like, what the hell, like, who are people you care about? And that's going to lead me to this second part, which is really about measurement on a social network. So how do you A/B test a social network? i.e., how do we know what we're doing and what kind of things are we actually trying to optimize for? Okay, so let's imagine we're not machine learning practitioners for a minute. We are just regular plain Jane engineers, maybe 10 years ago when machine learning wasn't such a hot field. And I'm going to ask you to define what is a person you care about. What is content that you actually care about? So you might go and you're like, okay, so there's probably some things that indicate interest in this person. Maybe it's people that I've liked in the past. It's people that I send direct messages to. Maybe it's people I search for. Maybe it's some abstract notion of people that I know in real life. And in a traditional approach, what we would do is like we take some sort of like informed stance, informed by our highly biased sample and our highly biased thinking, and we would kind of weight these signals and produce some sort of ranking function that's hand-tuned. And that might be an okay thing to do, but like I said, I mean, I'm saying highly biased for a reason because nobody can actually weight these signals effectively. So if you're a machine learning practitioner, this is the way I would like encourage you to think about this problem. It's maybe a little bit different than most people do. It's just like, what I try to think of is we're trying to pick a proxy for really user happiness. Like at the end of the day, what we want people to do is come to Instagram, be happy, enjoy their experience, come back more. But we can't really optimize for probability of being happy. So we kind of take proxies, and I'm just going to loosely call this engagement. So engaging on a piece of content indicates that you're interested in that content. And that's a proxy for your happiness in seeing that content. And instead of optimizing for happiness, you optimize for your proxy. Okay, so you use machine learning, and you use a bunch of signals to optimize for that proxy measure, like predicting engagement, and then you run a big test, you observe the results, and the results you measure on like whether your proxy captured your intuition. So you run this experiment. Are people that are exposed to it using the app more? Are there more people using feed? Are they producing more? Notice that I'm not really saying that you're actually looking at your proxy itself, because at the end of the day, that doesn't really matter. What really matters is, are you modeling something that's actually well-grounded for this user? So this is probably what you would think of. It's a control group and a test group. Let's say it's 1%, doesn't really matter. At our scale, at least, like most things are statistically significant on a day's basis. So your control group would get a reverse chronological feed, and your test group would get a ranked feed by some ranking function. And what would you measure after you've like observed these two test groups? You'd probably measure things like likes, comments, impressions, follows, time spent, pretty much any user attribute you can think of, and maybe you'd mix in monthly active users to see if people are coming back again and again. Those are the things that you can optimize. Like I can make you a predictor that on a piece of content will tell you how probable it is that you're going to like it. But it's really important to keep in mind that this is actually what you care about. It's really not likes or comments or whatever. Like you care, at the end of the day, are people using the app? So in our case, what we did is our proxy was this engagement, to loosely call it, and then using our chronological feed, which we had lots and lots of data for, unbelievable amounts of data. In fact, we have to sample it, there's too much data. We trained a function to predict that engagement. I'm going to call this for the rest of the talk, probability of engagement. And this is the thing we, as machine learning practitioners, we often get obsessed with. As product managers, we often get obsessed with, although I think this is like not the biggest deal, is what features are you using? So what kind of features did we use? Probably the obvious ones that you would think of. There's priors, engagement priors on the author-viewer relationship. There's empirically observed data, like we can see how this post is actually performing in real time, ... and so on. You can kind of make it up. Basically, we use anything that helps us make a better prediction. And we ran an experiment. We sorted by this probability of engagement, and that's what I alluded to at the start, is that we had this crazy increase, double-digit increase in feedback. And it wasn't limited to feedback. This is another, again, no y-axis here, but these are blue means positive, and everything's blue. And so daily active users, they're up. Impressions are up. Time spent is up. Photo uploads are up. In fact, it was almost impossible to find anything that was down. The only thing that I can think of is that people were searching less, which is actually, if you think about it, a good thing, because they're finding the content that they're looking for. So this got a lot of people inside the company talking. People are very excited. They're like, OK, obviously, there's no danger in this project anymore. We're obviously going to release this. But people are asking, what actually is going to happen when you take this limited experiment and deploy it at scale? What happens if you release? And as a person that was tech lead for this project, I was kind of like, oh, crap. I'm a dog. I don't know how to do science. And the reason I say that is yeah, I know that at a minimum, our A/B test results are likely to hold when we release publicly, at a minimum. But I actually don't really know what's going to happen in the network, which are these things called feedback loops. So this is something you often don't think about, and in a lot of domains this doesn't even exist. But in social networks, people that are viewing content are also the people that are producing content. And so that has a little bit of a problem in that you're ranking, OK, so you're ranking stuff, that's going to give more feedback to a given author. That author is going to be slightly happier or just have a better experience. And so they're going to produce more content. That production is going to give you more inventory in the system, which is going to let you do a better job of ranking. So by deploying a ranking function to the viewer, you've actually improved the viewer's experience through this weird loopy feedback thing, and improved the author's experience on Instagram, who you're not even testing on. So it's kind of like an inconvenient loop is what we call it. Usually, your A/B test is really measuring this first hop, if you will, actually just the node really, and the outbound edge, nothing about the inbound. So I'm going to tell you 3 ways that we came up with to measure these type of effects. There's probably more. It's something we actually active area of research or study for us. But here's the things that we did in that test period that I was talking about. Basically, there's 3 ways that we came up with. One is country tests. You probably can guess what this is. It's the type of thing that's very easy to understand. I'll go into more detail a bit later. There's network segment tests, which is a more mathematically sophisticated way of doing country tests, which is actually pretty cool. And then there's these effect proxies, which are very simple to understand and do a pretty good job of capturing the top-level effects. But let me just go through each of these in turn. So country tests. OK, what is a country test? Well, maybe what you'll do is you have networks in the world, and you have networks. Countries tend to be semi-closed. People in this case, this may or may not be true. I'm just using these as a test example, but the UK and Ireland share a lot of similarities. They have a common language. They're in a common geographical region. Not everything's the same, but they're probably pretty similar. And so you could run a test where you just expose one network, like the UK, to a certain experience, and then another network, like Ireland, to another experience, and then sort of measure how those 2 countries perform relative to each other. So, yep. Country test, pick a couple countries, Ireland versus UK, there's a classic example. You calibrate for pretreatment effects. This is a little bit of a subtle point, is like the Ireland and the UK are definitely not the same. They're going to have some sort of baseline difference, and basically you can train a function that, given the UK, predicts Ireland, and so that's like calibrating for pretreatment effects, if you will. Then you run your experiment on the countries. Again, this is super easy to explain to people. We can actually explain this in the press, like, hey, we're running a limited test in Ireland. We can see what happens. And everybody's like, okay, that makes sense to me. And you can compare the predicted effect, which is like this machine learning function from the UK. You project to the Irish effect. That's like what you should expect to happen if you didn't expose them to the experiment. And then you compare what actually happened. And you say that that difference is your test, like basically your experiment result, impact, if you will. So does this work? Kind of. There's a lot of problems. I think that these are not really often talked about. In fact, I have some trouble like even explaining this internally sometimes, is that like you're making a lot of assumptions here. One is that the difference between the UK and Ireland is going to generalize to the rest of the world, which probably is not true. Like if you imagine a more linguistically isolated society like Japan or Korea or something like that, like can you really say that the Irish effect between the UK and Ireland is going to be the same as like just what you see in Japan? Your results are going to be super noisy. There's not that many countries in the world, at least, not too many large countries for sure. And you're only going to have a couple of samples from these, so your variance is going to be like some super extreme thing. Random events that you never anticipated, like, okay, it's a bank holiday in Ireland, it's not a bank holiday in the UK, suddenly everyone's data is going crazy for no particular reason. You obviously can't do this, it's so infrequent, you can't build this into your like pre-calibration, so you're going to get just this crazy like effect that's not real on that particular day. Also, countries aren't really closed, so on certain graphs that are like bidirectional, this might be a better assumption, but on the Instagram graph, it's like directed, and so you can easily follow whoever you want, and often people follow celebrities that are in the US. So the Irish network is unlikely to be very closed. And your experiment didn't include these people that are in the US, these celebrities or whatever, so it's not going to really work perfectly. But there is a kind of a more sophisticated solution. This is something we actually pursued. And instead of like trying to find or try to just like find geographical things in the world that capture some network properties, we can just literally look at the social graph and find those network properties themselves. Concretely, like, let me say that this is your graph. It's a very simplified graph. You have two people, two viewers and two authors. One viewer follows one author, one other viewer follows two authors. And you can layer in a little thing here, a cluster that says like, this is cluster 1, this is cluster 2, and you optimize the cluster so that there's very few crossing edges. It's like a graph partitioning or a balanced graph partitioning because we want the number of nodes to be the same. And basically what you've done is you've divided your network into 10,000 little clusters, little countries, if you will. And you've constructed it so that it has the properties that you want. And at Facebook, we use something called social hash. There's other talks about that. We actually started it to improve our infrastructure, but now we've been able to use it to do these kind of cool things. And instead of running an A/B test on a country, you run an A/B test on a random subset of these clusters. So it's almost like you're exposing individual users, but instead of the user ID, you're exposing the cluster ID. And it's very probable, like by construction, you've constructed it so that the edges are in network. And so it's very probable that your feedback from a viewer to author is like the same cluster. And so you're capturing some of the effects that would be between the viewer and the author, and then the feedback loop that comes through it. And so you can project the kind of top-line effects. And, okay, does it work? Yes? Oh, it does. It does. There's always a caveat. There's always a but. And the but in this case is just, it's a giant, absolute mess, pain to ever do this. You need giant statistical samples. It gets out of date. You have to add people to the network. There's ambiguity about what to do if you don't have a cluster ID. There's just a lot of messy things. And so we only really reserve this for extreme things where we want to do a very precise sort of measurement. There's another thing we can do, though, which is if you look at this loop, probably the dominant effects are going to occur in the top half. Yeah, there might be a little bit more content production, but I don't think it's going to be the really spiral out of control. So I call this effect proxies. Another way of doing this is really you just look at the dominant effects, which are first order, i.e. the people you're testing on. Second order, which are the authors. And third order effects, like the author feeding back into the system, are going to be very, very small effects. So instead of doing a full country test, you can actually just measure the author response curve. And then using that response curve, you can actually project the top line effects. So concretely, imagine this is a feed. I'm going to conduct a reverse experiment, which is a little bit strange, but instead of exposing viewers, I'm going to expose authors. And so this middle author has been exposed to this experiment. I'm going to multiply the score by 2, which in effect gives you a little bit of a boost in feed. And then we can measure what happens. So you receive certain feedback, you do certain actions. And by construction, this is randomly selected, we can actually measure your response curve. So to estimate the network effects, we take the viewer side effects, we see how many outgoing edges there are, and we kind of multiply that by the effect of those outgoing edges on the authors, and that's what we use to project to the top line effects. Hopefully that makes sense. Okay, does it work? Yes? Sort of. I think this is my downside. There's a lot of downsides here. It's first of all, it's kind of a mess. You have to be very principled about what you're doing. And you kind of have to break down your graph in very clever ways. And in fact, you'll break it down in so many ways that you'll start to lose statistical significance within those buckets, and you're going to be in trouble. So you can kind of use it, kind of works, but we're still having problems with that. So there's 3 ways to measure the exact same thing. There's probably more. We're still investigating a lot more. And this is probably the biggest job that we have. For us, our country tests were extraordinarily noisy. We measured everywhere from 1x to 3x multiplier for the effects that we cared about. For network segment tests, which are these cluster, social hash, we measured a 1.5 multiplier for network effects of interest. And for these effect proxies, about the same. So the numbers don't really matter here. I think what you should take away from that part is really that there's something going on. And if there's something going on, it means that you're probably not optimizing for what you thought you were optimizing for, or there's a more optimal solution. So we can do better. And so this is going to be kind of more of a philosophical part of the talk, but let me talk about the gifting economy. And this is kind of the way I think about Instagram right now. And it comes from this poster I saw at Facebook one day. It says, feedback is a gift. Of course, in this case, it was talking about giving feedback to your manager or something as a gift that they'll receive. But I was thinking about that in another world, in my context, feedback, these actions you send from a viewer to an author, likes, comments, etc., are kind of a gift as well. It feels good to like things. It also feels good to receive a like. It's exactly like giving a gift, like a Christmas present or something. Giving it feels good, and receiving it feels good. It just requires a little bit of time. So on viewers, we've measured that giving more feedback makes your experience better. That was our original A/B test. On authors, we measured that receiving more feedback makes your experience better. And we know that demographics and all kinds of breakdowns affect how much effect there is going to be. And this means that what's optimal for the viewer is not really optimal for the economy, which is Instagram. The reason that this is the case is we have this power law. Basically, anytime you look at anything in our graph, it's going to be a power law. In this case, the power law is the follow graph or the impression graph. And most of the impressions are going to go to your the head. And then there's going to be an extremely long tail of people that you know in real life. And actually, sometimes you care more about the people you know in real life than you do about the head of this distribution. So we ran some experiments, and we had things like this. Again, no y-axis, but it's a breakdown of 2 ranking functions that we ran, where we're comparing the effect by the number of the follower count. We're bucketizing by the log of the follower count. And what you can see is that there's differences. So in one case, we're kind of giving a neutral, like everybody's winning in both of these cases, the effect is positive. But in one, it's more evenly distributed across the graph. And one, it's more, I guess in this case, tail heavy. It's boosting smaller accounts a little bit more. And which one's better? Well, I don't know. You kind of have to measure your effects and actually be very scientific and reasoned about these two things to make a judgment call about what's going to be better for your entire network. It's kind of a multi-objective optimization. Now, maybe we can simplify it more than that, but like basically we simultaneously want to optimize a viewer experience and the author experience. And they're kind of conflicting because as soon as you start optimizing for the author, you're going to corrupt your ranking function for the viewer a little bit. And so how do you balance the two? Our current state of the art is we kind of value engagement differently on different items. So the prediction is the same. We're predicting the probability of engaging on a particular item, but we're valuing the engagement differently. So there's the value of the feedback given to the giver, or by the giver, the act of giving this engagement. There's the probability of the engagement, which is the event that you're trying to predict. And then there's the value of the feedback being received by the author. And this can all be kind of fit in one framework, which is like maybe you combine the two effects, and that's your overall value. So the viewer side value of feedback, maybe up to a constant, you can just say it's 1. Viewers just are proportional to their engagement probability distribution. And author side value, you can actually estimate from author side tests. And the overall value is the sum of the two components. It's kind of what I've been hinting at. So under some assumptions, and again, like, sure, you could do like learning to rank and some blah, 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 but like basically this is what we're doing. And under some assumptions, we're maximizing expected engagement by sorting by the probability of engagement. And we're going to convert this very subtly to something else, where you multiply a value of that engagement, and now we're kind of maximizing the expected value of that engagement. I call this like economical health. I would state that this is currently what we're working on. It's a work in progress. There's always ways to automate things. Like I'm not super happy with the amount of hand tuning we have to do in our value model, but there's always ways to automate those sort of things. And I'm pretty sure these problems might exist outside of social networks, but it's just a very interesting example of when these effects actually started to be relevant for us. And the main conclusion here is just like optimizing for the ecosystem had a measurable and significant impact on top of optimizing for the individual predictors. Okay. In conclusion, just giving you a couple hints here, like this is our new modus operandi as a team, is that we run a viewer-side experiment, like an A/B test, new model, whatever you want to do. Maybe you throw in some different probability that wasn't there before. If the results are absolutely insane, you want to be extremely precise, and so you'll run some sort of network test, like a social hash test. And of course, you'll ship it if the impact is positive. You don't think this has significant, downsides to it, and that can be non-numeric as well. If the results are like good but normal, like you're not, calling somebody just very happy, you would probably just determine the downstream impact by our like predicting the author side effects. And of course, you would ship if the predicted impact is positive. So I look at our team as more of like a central bank. We're kind of like, chairman of the Federal Reserve basically now, making decisions about the overall economy from, I guess, somewhere, a centralized location. And if I had to like convert this to some takeaways for ML practitioners, even some ML researchers, is like, you should probably think about what you're measuring. Like, we get caught up in this game of trying to beat metrics. I can make a better predictor that has a slightly better AUC or whatever. But actually what you care about isn't really this prediction that you're trying to make. It's actually user satisfaction with your product, or maybe it's advertiser satisfaction, or maybe it's investor satisfaction, but it's something like that. It's probably not what you're actually optimizing directly. And so you have to keep that in mind. And it's really important to like actually construct your conclusions based on user satisfaction versus your like individual metric. Like, if you optimize for search clicks are probably going to go up. But is that a good thing or a bad thing? I don't know. Sometimes clicks are bad. You should definitely know the limits of your experiments, and you should probably reason through them. Like, social networks are just full of weird interaction effects that you wouldn't see probably in an academic setting. So think about what you're measuring and like think about if your test is actually pure. And also just machine learning is really more than a bunch of algorithms. So here's the thought exercise is basically if you gave me a 100% precise, got a 100% precision recall classifier that told me if somebody was going to engage on a piece of content, I would still have a job. You know, like I would still need to know how to value those predictions that you're giving me, even if they're perfect. And so I would just encourage you to make your hand tuning absolutely as grounded as possible. And I'm happy to take any questions.
Question over here.
I'll need some
This side.
Oh, okay.
So regarding your unfortunate interaction effects, or whatever you call them,
Yep.
It seems like the fundamental problem is that there's a bias introduced in the data flow, right? You have some data you're training on naturally, and then this other stream comes in from the interaction effects, and you're not sure how much it's affecting your learning, right?
Yep.
But there's a large body of literature on exactly how to deal with that by introducing exploration. Mm-hmm. So contextual bandits, algorithms.
Right.
Like
so actually,
I
I wouldn't say that the problem really is that in particular, that we're biasing our predictions in some way. That is a problem. Like we are biasing our predictions. But of course, you're biasing your predictions because you're changing the way you're ordering content. I think that the real problem is that your predictions are having a different effect that you may not be measuring. So it's like a slightly different thing. Even again, same thing. Like even if we had perfect predictions, this effect would still exist. That we're actually in some ways corrupting, like not corrupting, but like improving another person's experience that's not in our test group, or is not in the group that you're like actually seeing the ranking function. Does that make sense?
Right, but you should still be able to measure that, all right?
Yep. That's kind of the idea, if I'm understanding correctly.
And you should be able to measure that in an unbiased manner.
Yeah, it's more or less like what we're trying to do is we're trying to measure what affects, like what is the effect, the overall effect of exposing the entire network to an experiment.
Really quick question. You predicted engagement as a proxy for happiness. What level of aggregation, hourly, daily?
Oh, it's on individual items. So we need kind of a classifier that's discriminative enough to like order content.
Okay.
And so, of course, our measurements are like basically daily or weekly. Like after we like expose the experiment and train our functions and all that, we kind of like compute the overall effect over long periods of time, sometimes months, sometimes years. But the actual predictions are done at an individual piece of content level.
Thanks.
So you sliced by, oh, I'm looking straight ahead of you.
I have no idea where I'm looking right now. Okay, yeah, sorry, it's blinding light in my face, but.
It happens. So you sliced by cluster and by country, but I'm wondering if you ever sliced by time, which is to say, like, if you have the control on the experiment and you launch the experiment, you see the metrics go up, do you ever track people after the fact to see what happens if you unlaunch?
Oh, yeah, sometimes we do that. I don't get into too much detail, but people are surprisingly responsive, I think.
And then my other question built upon that would be, do you ever do it like longer down the road, like 6 months to a year? Because if you have a network effect that's actually changing the entire environment, then it's possible that what you're doing might no longer be necessary, might not have the effect you kind of want. So do you ever do ablation experiments?
So long-term holdouts, long-term experiments are probably the most important thing we can do. It's really the only way we can know what we're doing long-term. And also, this is like a subtle issue, not really necessarily related, but like, let's say you have two experiments, model A and model B, they're both ranking models, and suddenly your infrastructure gets corrupt. This happens all the time. Like, I don't know, somebody puts some buggy line of code that like multiplies some feature by some random number. Oftentimes that will affect both model A and model B in the same way. And so what'll happen is like you actually won't see any effect in your test control group, but you'll start to notice that your top line effect, like, hey, people are using the app less, hey, we're getting a lot of complaints, blah, blah, blah. And so the only real way to do that is have like a long-term kind of ranking function that's not really a ranking function or it doesn't depend on features. So very important things to do. In fact, that's maybe even more important than overall estimating the network effects is just keeping those long-term holdouts.
Cool. Thank you.
Hey, so every chart you showed went up and to the right,
Yep.
and then I spent a lot of your talk wondering what would have gone down and to the right.
Right. Yep.
My best guess was maybe the survival time of a post. If I don't get feedback right away, I'm forever not going to get
So
feedback.
I don't
Did you
want to
find
get
anything that went down? Is the question.
I can't get into too many specifics, but it was surprising to me. Like when I say everything was up and to the right, I almost mean that. Like it was a shocking thing to me. Like I was even in some ways skeptical about this project because I was doing it, but I was also like, I don't even know if this is a good thing for the community. In every way that we can measure it, I mean, we've lost some understandability, but everything that we can measure on people's behavior and stuff is like positive. The only negative ones that I could say are like trading between time and different parts of the app. Instagram's pretty simple, but like there are a couple of tabs, and if you make one really good, suddenly people use the other ones less, to an extent. But we just treat that as like, okay, we're shifting time around, let's do a better job on the other tab later.
I was just wondering, so when you do your clustering for tests, have you noticed differences in behaviors between different clusters? Do you account for those? So
Yeah,
for example,
definitely.
some behaviors have more lurkers, fewer posters, some have more.
So yeah, when you do clusters, like you're going to get clusters that are going to be like Philadelphia, and like obviously that's some interesting city that has a different cluster behavior than like New Delhi or something. So the effects are going to be very different. You can still do one thing that you're doing is you're not selecting individual clusters, you're actually selecting a random subset of the clusters. So that's going to help reduce your variance. You're not taking like a point-wise sample, you're actually taking a bunch of them and kind of averaging them together. Even that's sometimes not enough, and so you'll actually still have to calibrate for pre-treatment effects, which is basically the same thing we did in country tests, but it's a little more principled because at least your selection process is like somewhat unbiased. Yeah.
Thanks.
Yeah. So it's an interesting talk. Network effects and feedback, those are all really good points. And maybe the social media is in this crazy growth period where you could imagine a vicious circle where it'd be like a money pump. There'd just be no limit to how much growth you could have.
Sure.
But in mature businesses, there's some evidence that there's only so many people on the planet and only so many hours on the day. Mm-hmm. And telephones before cell phones, the data is pretty clear. There was a sort of limit of about an hour per person per day. Mm-hmm. And in television, apparently, it was 4 hours per person per day. But I would think, I don't know, but I would think there's got to be some asymptotic limit to how much this money pump could pump before it would exhaust the supply of
yeah, that's probably true. Although we usually benchmark, because we're Instagram, we're owned by Facebook, we usually benchmark against Facebook, which is, I don't know what it's like somewhere very close to 2 billion monthly active users. Instagram is like the last public number is 600 million or so. And so we're actually a ways off, at least from that perspective. I don't know it's a good question about the network effects. Like, you can only like so many things. There is a fundamental limit to that. I guess there definitely is a limit. And obviously, as machine learning people, your biggest effect is going to be going from no ranking to ranking. And then the rest of your effects is going to be going from ranking to slightly better ranking to slightly better ranking to slightly better ranking. Those step functions don't come around too often, but sometimes they do. Recently, something that our team has been doing is actually we introduced a new product inside of Instagram, which is Instagram Stories, and we did the ranking for that, and that actually just kind of opened up a new product area. So in some ways created we call it growing the pie, So maybe we shrunk the proportion of certain areas, but we grew the overall pie.
So you don't see any of these limits kicking in anytime soon?
It's hard for me to answer. There's certain limits that we see every day, but we know that certainly Instagram is not as big as it could be, and we hope it continues to grow. I think to some extent, photos are kind of fundamental to people, so I don't know why we wouldn't be able to grow to the size of some other social networks.
Excuse me. Yeah.
Yep.
So this entire thank you for a great talk. So this entire talk is about like focusing on the engagement, like all the objectives are that. And I just want to know that because engagement seems like something that's very subjective. It's
Yes.
not like an objective like functions.
Yes.
So like how to do, like what is that? And if that cannot be said, then what's the process for sort of creating this objective that everyone agrees this is something good to optimize for?
It's a good question. I can't get into specifics on that. That's actually why I used engagement, is because there's some ambiguity to it. You can imagine that there's like lots of things on the network that we could predict, and in some ways we can kind of compare the effect of optimizing for certain things versus certain other things, and that kind of gives us some sort of curve that we can balance. But the short answer is there's lots of experimentation, and
is there a fixed process to sort of reach the conclusion that, okay, this is the object we want to do? Is that shareable or?
I certainly can't share that, like, again, what exactly we're doing today, because it also might be very different than what we do tomorrow, like literally tomorrow. There is obviously a process to all this sort of stuff. We move very, very quickly inside of Instagram, and I'm very happy about that, but it doesn't mean that we're like YOLO shipping every day, you know, like there are people that kind of look at what we're doing as well. And even internally, like, it's kind of, our team is very academic in some sense. Like, we have experiment reviews where we all get into a room and argue with each other about whether our experiment is good or not, because sometimes it's super unclear. It might be good over here, bad over there, and then we're like, no, that's bad, no, that's good. Well, here's some science. So there's like even an academic debate about whether we should ship something or not, in addition to kind of like the regular checks and balances that you might imagine.